Amid the vast silence of Egypt's western desert, where the sun burns relentlessly, the land cracks under centuries of drought, and nothing moves except the wind, Egypt attempted one of the boldest engineering experiments of the modern age. In a region where life had vanished thousands of years ago, engineers decided to bring it back by doing something nature itself refused to do. They forced water to flow uphill, across rock, sand, and scorched earth, into land the desert had claimed long before recorded history. This was not a natural river. This was not rainfall or underground water. This was a man-made lifeline, carved with steel, concrete, and machines powerful enough to challenge the desert itself. This is the story of the Toshka Mega Canal Project, Egypt's attempt to reclaim dead land and reshape its future. The crisis, a nation trapped along one river. For thousands of years, Egypt's survival depended on a single source, the Nile River. While the river brought life, it also imposed a hard limit. By the late 20th century, more than 95% of Egypt's population lived on just 5% of its total land area, tightly packed along the Nile Valley and Delta. Population growth surged, cities expanded, and fertile lands shrank year after year. Farmers divided fields into smaller plots. Urban areas swallowed agricultural land. Pressure on water resources intensified. Yet beyond the green strip of the Nile lay an enormous desert, vast, empty, and seemingly useless. Egypt faced a defining question. Should the nation remain trapped along one river or attempt to bring the river to the desert? The vision, creating a new valley. The answer came in the form of an audacious plan. Engineers proposed diverting excess water from Lake Nasser, the massive reservoir formed by the Aswan High Dam, and transporting it westward into the desert. The goal was to create a new valley, capable of supporting agriculture, settlements, and economic growth far beyond the Nile. But the challenge was immense. Lake Nasser sat lower than much of the surrounding desert plateau. Water could not flow naturally. Gravity was useless. To succeed, Egypt would need to lift millions of cubic meters of water every day, then guide it across harsh terrain under extreme heat. The project would require power, precision, and machines on an unprecedented scale. The heart of the project, the Mubarak pumping station. At the core of the Toshka project stands its most critical component, the Mubarak pumping station. This massive structure was designed to lift water more than 50 meters vertically, overcoming gravity before the water could even begin its journey into the desert. Inside the station are 24 enormous vertical pumps, each weighing hundreds of tons, each driven by high-power electric motors, capable of moving over 25 million cubic meters of water per day combined. The station operates continuously, day and night, under intense load. The reinforced concrete structure was engineered to absorb vibration, resist heat expansion, and maintain perfect alignment despite constant mechanical stress. Without this pumping station, the Toshka Canal would remain nothing more than an empty trench. Carving the Toshka Canal. Once the water could be lifted, the next challenge began. Cutting a canal through the western desert itself. The Toshka Canal extends more than 50 kilometers, with additional branch canals spreading even farther. Its size was carefully calculated to balance flow speed, evaporation loss, and erosion. Construction crews faced brutal conditions. Daytime temperatures often exceeded 115 degrees Fahrenheit. Sandstorms could halt work instantly. Equipment overheated. Metal expanded under the sun. Thousands of excavators and bulldozers removed millions of cubic meters of sand and rock, shaping a wide, gently sloping channel that could carry water without destroying itself. Surveyors worked constantly, using laser leveling instruments to maintain precise gradients. A deviation of even a few centimeters could lead to pooling, erosion, or structural failure over time. The desert allowed no mistakes. Stabilizing a land that resists water. Desert soil presents a unique challenge. It absorbs water rapidly, shifts under load, and erodes easily once saturated. To prevent collapse, engineers reinforced the canal bed and slopes using multiple layers, compacted clay to reduce seepage, geotextile membranes to separate soil layers, concrete linings in high-risk zones, reinforced embankments to prevent erosion. In areas where wind erosion threatened the canal, engineers planted vegetation belts to anchor the soil and slow sand movement. What emerged was not simply a ditch filled with water, but a carefully controlled hydraulic system designed to survive decades of desert exposure. Distributing water into the desert. From the main Toshka Canal, water is divided into 4 major branch canals, extending deep into what became known as the New Valley. These branches supply large agricultural developments, experimental farming zones, irrigation networks designed for desert efficiency. Traditional flood irrigation was impossible here. Instead, modern systems such as center pivot sprinklers and drip irrigation were deployed, delivering water directly to crops while minimizing evaporation. From above, satellite images reveal a striking transformation, bright green circles and geometric fields emerging from endless brown terrain, a visual proof that water had returned to the desert. The first flow, when the desert changed. When the pumps were activated and water entered the Toshka Canal for the first time, it marked a moment years in the making. Water flowed across land that had not felt moisture for thousands of years. Dry soil darkened, dust settled, heat shimmered above the surface. For engineers and workers who had spent years battling heat, sand, and mechanical failure, this was more than a technical success. It was confirmation that the desert could be challenged and changed. The results: success, struggle, and reality. The Toshka Project delivered both achievements and challenges. It succeeded in reclaiming hundreds of thousands of acres of desert land, creating new agricultural zones outside the Nile Valley, reducing population pressure on the delta, testing large-scale desert irrigation technologies, expanding Egypt's long-term development options. However, the project also faced criticism: high costs of pumping and maintenance, dependence on Nile water availability, slow settlement growth compared to expectations. Despite this, Toshka remains one of the most ambitious land reclamation efforts ever attempted in Africa, not as a finished solution, but as a long-term national experiment. A project designed for decades. Unlike short-term infrastructure projects, Toshka was designed to operate over generations. The canals, pumping stations, and irrigation networks were built first. Development would follow slowly, shaped by economic conditions and water management strategies. In a region where water defines survival, Egypt chose not to wait for nature. It chose to engineer its future. So now you've learned the full story of how Egypt attempted to reclaim thousands of acres of dead desert land by lifting the Nile itself and forcing water to flow where it never had before. Do you believe mega projects like Toshka are the future of desert nations? Let me know your thoughts.